The second application of differentiation is on increasing and decreasing function. Okay, actually, this concept is very simple. There's only one concept to understand. Now, if you look at the graph over here, when is this graph increasing? It is from here to here. So when it is increasing, right, what can you say about their gradient? All their gradient will be going upwards, going upwards, going upwards. So that's why when you see an increasing function, straight away apply dy dx greater than 0. Okay, when it is decreasing function, means the tangent of the curve is going downwards. Okay, so when it is going downwards, then the gradient is less than 0, is negative. That's where you get a decreasing function. So only these two concepts for increasing, decreasing functions. But the question can ask in many ways. First type of question is related to your chapter 2 quadratic inequality. Okay. Now, in this case, the question asks for the range of values for which this function is a decreasing function. Okay. So decreasing function means first I go and differentiate dy dx, and I say that for decreasing function, dy dx is less than 0. This is a standard presentation for O levels or for your exam. So when you get a decreasing function that is less than 0, now this is a quadratic inequality. Mr. Ivan always says that when you do quadratic inequality, make sure your x squared is positive. So I multiply by -1 on this side, and I multiply by -1 on this side. When I multiply by -1 on both sides, my inequality sign must change. After that, I factorize and I get the roots. So remember your chapter 2 quadratic inequality, label the roots. -2 comes from x plus 2. X minus 3 will give you the roots of 3. Now, plus minus plus. When it is greater than 0, I circle here and I circle here. So therefore, my final answer is x less than -2 or x greater than 3. Okay, to recap your quadratic inequality, let me use a blue pen. If let's say I have x minus 3, x plus 2 less than 0. Okay, so where should I circle? I will circle the in between part, and hence my range of values would be x in between -2 and 3. So this is quadratic inequality. Okay, sometimes the question can ask you to show that a function is increasing or decreasing. Students are generally weak in show that question, because show that is to try to explain. It's not try to apply the concept that is greater or smaller than 0. So if I want to show that the dy dx is greater than 0, first I differentiate, I get dy dx. Let me use a red pen. Okay, now how do I show that a polynomial, this is a polynomial or rather a quadratic function, is greater than 0? It's a bit like showing that this equation has real and distinct roots, like showing the b square minus 4ac. We got to use complete the square. That's where I put it down here. Okay, take out the 2, make sure your quadratic function is x square only, plus 1 square minus 1 square. Where does this come from? Remember, you're completing the square. X square minus 2x plus 9 over 2 with a 2 on the outside. We always need to add the half of the coefficient of x square, and then we minus away because this does not exist in the first place. Why do we need to add this 1 square? Is so that my first 3 guys can complete the square to become 2 big square bracket x minus 1 whole thing square. Behind, use your calculator. It's going to be plus 7 over 2. I multiply the 2 to the first bracket, multiply the 2 to the constant behind. That's where I will get 2 bracket x plus 1 square plus 7. So in your chapter 1, A Math Sec 3, okay, and square number is always greater than 0. When you plus 7, it's even more positive. All you need to do is to say that, oh, this function is greater than 0, which means the dy dx is greater than 0. Hence, y is a increasing function. Okay, so this is one way of showing, okay, a function is increasing or decreasing. Sometimes maybe you get something like this. Oh, dy dx is equals to -4 over x minus 1 square. Straight away you can say that this dy dx is lesser than 0. Why? Because a square number is always positive. So when you have a negative 4 over a positive number, the whole function is less than 0. Then that's where you say, oh, therefore y is a decreasing function. Okay? So this is how you do show that questions for increasing, decreasing function, as well as finding the range of increasing and decreasing function.